You're a very accomplished scientist in NLP and machine learning. You started as a computational linguistic researcher. Can you briefly walk us through your journey towards deep learning?
Sure. So I'm old enough that I was around and saw a little bit of the second time that neural networks gained popularity, the parallel distributed processing or connectionist era of the late 80s, early 90s. And I guess at that point, while I was a grad student at Stanford, Dave Rumelhart was at Stanford, and I took his neural networks course. And so I sort of saw a little bit then, but it's not really something that became my research area. So in terms of then what happened in the late 2000s decade, then going into the early 2010s, really the proximate cause of getting into doing deep learning research was at that point, my office was next door to Andrew Ng's, and Andrew had become really enthusiastic about this being the way to make progress in general cognition. And I guess I got caught up in his excitement.
And what did you see at that time as being the biggest challenge from a research community perspective?
So I'm not sure if this was the big challenge from the research community perspective, but very clearly for me, the starting off point was remembering back to the 1980s, there'd been a lot of controversy about how effective neural networks were as a model for human language. And one of the big things that seemed to be missing was that human languages have a compositional structure where words go into phrases, which go into clauses and sentences that can embed in bigger sentences. And the kind of flat neural network architectures with fully connected layers of the 80s, and indeed that were starting to be used again around the late 2000s, that they didn't seem to give any way of doing a good job at modeling this hierarchical recursive structure of human language. So the thing I was initially really enthusiastic about was how to make progress on that. And so that for the work that was done at Stanford starting around 2009 till 2014, 13, roughly, a lot of which was done with Richard Socha, that really the dominant idea was how can we start building tree-structured recursive neural networks and exploring those ideas.
And at the same time, as we looked at how industry was developing and we were starting to get introduced to Alexa and so forth, what did you think about that transition from what was happening in the academic world then, what was being reflected in the consumer world?
So certainly something that's had a huge impact on NLP and NLP thinking has been the rise of these dialogue agents, things like Alexa and Siri. I mean, in the first instance, that didn't really have anything much to do with deep learning and NLP, because essentially all the work was these very hand-scripted dialogue agents. So really that was a re-emergence of rule-based NLP more than anything else. It wasn't even really machine learning, probabilistic NLP of the kind that I'd been mainly doing from around 1995 till 2010. As the years have gone by, there's been a lot of interest, and I've worked a little myself in looking at how to build neural dialogue agents. And I think that's an interesting area to push further. But in some sense, it's been a hard area. I guess last week in Long Beach was the ICML machine learning conference, and there was a tutorial by a couple of Microsoft researchers on building conversational dialogue agents. And I mean, one of the central points that they were wanting to make is that the reality still isn't that people can just train end-to-end complete neural dialogue agents and expect them to work, that all of the deployed systems are some kind of mixture between machine learning and neural components, and lots of stuff that's still quite hand-coded.
Yeah, absolutely. We're still a long way to go. So if we look at where you are currently, you're leading Stanford AI Lab. Given the breadth and depth of AI, can you tell us a bit about your current research focus?
So, are you meaning for the research focus of Stanford AI Lab in general? Yeah. Okay, not me.
Yeah. For Stanford,
okay.
The lab, yeah.
So I'll answer for that. The truth is that Stanford AI Lab is a fairly loose structure, right? It's just not the kind of place that there's a director whose job is to tell other people what research to do, that really individual faculty are deciding for themselves what they want to do, and basically that's what happens. But nevertheless, I mean, you can see clear trends. So the influence of deep learning in particular and machine learning in general is just pervasive. That now is sort of affecting almost all areas of what goes on. There are a few places where it doesn't. There's still quite a bit of robotics work done with handcrafted control systems, but the vast majority of work is machine learning and deep learning. There's been a huge growth and emphasis in areas like NLP and vision that I think they're now sort of almost dominant areas of the Stanford AI lab, where that didn't used to be the case a decade ago. Something else that's exciting that's happened in the last few years is that we've hired a couple of great new roboticists, and so there's a lot of new robotics life around the Stanford AI lab. And then there are many other areas. So there's also a lot of work in machine learning, some of it applied to particular problems like computational sustainability, some of it looking at reinforcement learning and its applications to education, things like that. So lots of different threads of work.